back in 2017, a team of researchers at Google published a paper with a pretty simple title. But this paper didn't just suggest a new idea. Oh no, it kicked off the revolution that led directly to the AI we're all using today. So let's dive in and break down the paper that really did change everything. Attention is all you need.
To really get why this paper was so groundbreaking, we have to start with the big question that researchers were wrestling with, right? How do you teach a machine to not just read words, but to actually understand the complex web of relationships between them? The stuff that creates actual meaning. Well, a massive part of the problem was something you could call the sequential bottleneck. And this wasn't a small issue. It was a fundamental roadblock baked into pretty much all the AI models at the time.
Okay, I want you to imagine trying to read a long, complicated paragraph, but you can only see it through a tiny little straw, one single word at a time. Sounds impossible, right? Well, that's exactly how older models like recurrent neural networks, or RNNs, had to work. They processed language in a sequence, and that created some huge problems.
And this comparison really lays it all out. On the left, with the old RNNs, you can see the issue clear as day. Processing one word at a time meant that by the time the model got to the end of a long sentence, it had probably forgotten what was said at the beginning. It was slow, and you couldn't really speed it up with modern computer chips. The transformer on the right came in with a totally radical idea. Just look at all the words at the same time. And if you want the nerdy proof, this table from the paper says it all. Now don't worry about the complexity column, just look at sequential operations. For an old-school recurrent network, the number of steps it takes to connect words grows the longer the sentence gets. That's what O of n means. But for self-attention, it's O of 1, a constant number. It doesn't matter if a sentence is 5 words or 500 words, the model can connect any 2 words instantly. This was a complete and utter game changer.
And that right there brings us to the breakthrough itself, the elegant and incredibly powerful solution that was presented in this paper. This one sentence from the paper's abstract was basically a declaration of war on the old way of doing things. The authors weren't just tweaking something, they were proposing a whole new architecture, the transformer. And their big, bold idea was to throw out the sequential parts, the recurrence, entirely. So what did they replace it with? This beautiful concept, self-attention. Think about how you actually read something. Your eyes don't just go left to right, do they? They jump around. They dart back to check who he refers to or to connect a complicated phrase. Well, self-attention gives an AI that exact same superpower, the ability to look at the entire sentence at once and figure out for every single word how important all the other words are to its meaning. So how does this new transformer thing actually work? Come on, let's pop the hood for a second.
At its heart, it's a 2-part system. First, you've got the encoder. Its job is to read the input text. Let's say an English sentence, all at once. Using self-attention, it builds this super rich contextual map of that sentence. Then, the decoder gets to work. It starts generating the output, say the German translation. But here's the magic. For every single word it creates, it's allowed to look back, or pay attention, to that entire map of the original sentence. But the real secret sauce, the little detail that made this so unbelievably powerful, was an idea called multi-head attention. Instead of having just one attention mechanism trying to figure everything out, the transformer uses several. The original paper used 8 of them. Think of it like a panel of experts all looking at the same sentence. One expert might be focusing on grammar, another is just looking for who did what to whom. A third is figuring out the overall vibe of the sentence. By working together, they build a much richer, more complete understanding than any single one ever could. Okay, so this all sounds amazing in theory, right? But did it actually work? Oh yeah, the results weren't just good, they were absolutely jaw-dropping. So on the standard English to German translation test, the transformer got a BLE score of 28.4. Now that number probably doesn't mean much by itself, but trust me, this wasn't a small improvement. It completely blew past the previous best models, even the really complex ones that were basically teams of models all working together. And it wasn't a fluke. For English to French translation, it set another record with a score of 41.8. This was a new state-of-the-art, proving this new architecture was the real deal. But here's the kicker. This is my favorite part. Look at this chart. The transformer got these amazing results while being way, way more efficient. We're talking a fraction, less than 1/8 in this case, of the computing power to train compared to the old champ. It was better, faster, and cheaper.
In the world of AI, that is the holy grail.
So these results didn't just win some academic contest, they fired the starting pistol for a whole new era in artificial intelligence. And you can literally see the shockwave spread from here. This timeline says it all. 2017, the paper drops. Boom. Just 1 year later, Google releases BERT. Then in 2020, OpenAI's GPT-3 shows everyone what happens when you pour rocket fuel on this idea. And today, every single major AI model you've heard of is built on the foundation that was laid in this one paper.
So if there's one thing to take away from all this, it's that by solving that old sequential bottleneck, this one elegant idea of self-attention unlocked the massive parallel processing power needed to train the giant AI models that are literally reshaping our world today.
It's really an incredible story about how one clever insight can change an entire field overnight. And it leaves you with this really fascinating question, right? If a single shift in thinking, like attention, could unleash all this, what's the next huge breakthrough that's just out there, hiding in plain sight, waiting for someone to find it?